Hello everyone. In this lecture, let's configure our ATMEGA16 microcontrollers I2C bus for interfacing devices such as EEPROM to it. Let's get started. So we are just going to see several functions that is used for communicating with the I2C bus in our ATMEGA16 microcontroller, and all the functions that we are going to see in this lecture are common for all the devices that are working on I2C bus. So you can use these functions for interfacing any device that is working on I2C bus. Let's get started. So the first function is I2C initialize, and this function is used for setting the frequency for I2C communication. As per the datasheet of our microcontroller, our I2C communication maximum speed is 400 kHz. So we are just going to set the frequency to 100 kHz. For that, we just want to load the corresponding value to WBR register. For that, we are having a formula, that is this one. Using this formula, we know that SCL frequency is 100 kHz and the CPU clock frequency is 16 MHz. And this TWPS is nothing but the prescaler for the communication, and I just want to set the prescaler to 64. So I am setting these two bits, and we just want to find the corresponding value of TWBR value. That formula I have written here. You can see this FCPU is nothing but 16 MHz, and this is the 100 kHz frequency that we want to set. And this prescaler, I am just setting these two bits in the TWSR register, and for all this value I am loading the result to the TWBR. So thus this function is used for setting the frequency for I2C communication. And the next function is I2C start, and this function is used for sending a start bit to the I2C device along with the slave address of the device. In the first line you can see we are setting few bits in the TWCR, that is the two-wire interface control register, that is this register. We are setting the TWSTA, that is the two-wire interface start condition bit. Two-wire interface start condition bit, we are enabling this, and then we are enabling the two-wire enable bit, that is this one, two-wire interface enable bit, and then we are clearing the two-wire interface interrupt flag by writing 1 to it. That is done using this line. Once we have sent the start bit, or once we have initiated the start bit here, once the start bit is executed, this interrupt flag will be raised. So we are waiting for this interrupt flag to be high. Once it is high, we will come out of this loop. After that, we are writing the address to the two-wire interface data register. This TWDR is the two-wire interface data register. So we are loading the address to the data register, and we are enabling the two-wire enable bit, and we are clearing the two-wire interrupt flag in the control register of two-wire communication. Once we have enabled the communication, and once the data is fully written, this two-wire interrupt flag will be high, and we will come out of this loop. And thus this function is used for sending the start bit along with the slave address of the device. Nextly, we will see the I2C repeated start function. So this function is used for sending a repeated start bit from our microcontroller to I2C device. So this is the same line that we saw in the previous function. We are just enabling the start bit, enable bit, and we are clearing the interrupt flag. After that, we are waiting for the start condition to be executed using this interrupt flag. Once it is executed, we are loading the address to the data register. After that, we are enabling the two-wire enable bit, and we are clearing the two-wire interrupt flag. Then we are waiting for the write operation to complete using this interrupt flag. Once it is high, we will go out of this function. This is similar to the previous function, right? After that, we are going to see I2C stop condition. So this function is used for sending a stop condition from our master to I2C bus. For that, we just want to enable the TWSTO, that is the two-wire interface stop condition bit, and we just want to clear the two-wire interface interrupt flag, and then we just want to enable the two-wire enable bit from the two-wire control register. As you can see, this is the two-wire interface stop condition bit. We are doing this, and we are clearing the flag by writing 1 to it, and we are enabling the two-wire enabling bit. So we have initiated the stop condition here, and once the stop condition is executed, this TWSTO will be raised. So we are checking for that in this condition, and once that is raised, we will come out of this function, and that's it. And the next function is I2C write. This function is used for writing 1 byte of data from our microcontroller to I2C bus or I2C device. So the first step is we just want to load the data to the data register, that is TWDR. Before loading the data to the I2C bus, we just want to convert the decimal data into hexadecimal using this decimal to BCD function. We are just going to discuss about this function, and we are loading the data to the TWDR, that is the data register. After that, we are enabling the 2-wire enable bit and we are clearing the interrupt flag by writing 1 to it in the control register, that is TWCR. Then once the 1 byte of data is written to the I2C bus or I2C device, this interrupt flag will be raised. So we are checking for that flag to be high, and if it is high, we will come out of this function, and thus this function is used for writing 1 byte of data to the I2C device. And the next function is I2C read acknowledgement or I2C read ACK. So this function is used for reading 1 byte of data from I2C bus to the microcontroller and then for sending acknowledgement signal for the received data. So in the first step, we are just going to enable the TWEN, that is the 2-wire interface enable bit, and we are going to clear the 2-wire interrupt flag by writing 1 to it, and then we are going to enable the TWEA bit from the TW control register. Let's see what is this bit. This bit is nothing but the 2-wire interface enable acknowledgement bit. So for sending an acknowledgement once the data is received, we just want to enable this bit. Once the 2-wire communication is enabled, we will wait for the interrupt flag to be high. Once the complete data is read from the I2C bus to the device or our microcontroller, this interrupt flag will be raised and we will come out of this loop. After that, we can read the TWDR, that is the data register of 2-wire communication, which will be holding the data read from the I2C bus or I2C slave device. And once the data is received, the master will be automatically sending an acknowledgement signal to the slave since we have enabled this bit. So thus this function is used for reading data from the I2C communication. And the next function is I2C read NAC. This function is similar to this function except that we are not enabling this TWEA. So the change made for this process is simple. Instead of sending an acknowledgement bit, the master will not respond to the data received. So you can see here we are enabling the TWEN and we are clearing the interrupt flag. After that, we are waiting for the flag to be high, and if it is high, one complete data is received. So we are returning the data register value, which will be holding the I2C data received from the I2C bus. So once the data is received, the master will not respond to the slave. That not response will be taken as a not acknowledgement bit by the slave. So that is why this function is named as I2C read NAC, and this function is named as I2C read ACK. So these are the functions that we are going to use, and in the next lecture we will be interfacing 24C32 EEPROM using I2C bus of our ATMEGA16. See you in the next lecture. Thanks for watching.